Oh, hello everybody. This is Mr. Folly, and welcome to 11.1, identifying acids and bases. So we get to learn a little bit about acids and bases from me, your host, Mr. Folly. All right, acids are H positive givers in solution. Remember, H positive is the exact same thing as a proton. It's the exact same thing as a H3O positive. Completely, totally, 100% interchangeable, just like your parents and Santa Claus. So really, they're the same thing. HCl is an acid in water. That means it's going to give H positive. CH3COOH is an acid in water. This is the H that you give. This is the only one. Okay. NH4 positive is an acid in water. See the H that it can give? Water is an acid in NH3. So water is H2O. So see how it's got an H it can give? Sometimes it gives it, sometimes it doesn't. So let's take a look at what those reactions look like. If HCl gives an H to H2O, it becomes H3O positive. Now remember, we're giving H positive. So I get an H and I get a positive. Cl negative's left over. CH3COH, this is the H it's going to give. H3O positive. Okay. H2O and NH4 positive. So here NH4 positive is going to give its H to water. If it loses an H positive, NH4 positive becomes NH3. And you can see how this works, okay? Now water in this case is also an acid, so H2O gives its H. Keep making NH4. Then you get OH negative. All right, so let's take a look. Acids can be identified by their formula, okay? So acids start with H. I say that H says, hello, I'm an acid. Hello, I'm an acid. They can end in something, COOH. This is the hello, I'm an acid part. They can end in NH3 positive or exactly NH4. So see this right here? This has an extra H, and it can be an acid. Bases are H positive receivers in solution. So if NH3 is the base, this must receive an H positive. NH3 combined with H positive makes NH4 positive. And that's what happens. Okay. Water is the base here, so water has to receive an H positive. H2O mushed with H positive makes H3O positive. Okay. Strong bases are group 1 and 2 hydroxides. So strong bases ionize, and we just focus on their OH negative. Okay, and they actually ionize. You need to have that word 100% in there. So I bet that's on the pod quiz. How much do strong bases ionize? 100%. NaOH, as far as we care, is just OH negative. BaOH taken twice, as far as we care, is just 2 OHs. So notice how this doesn't do anything. So it's just there. Okay. Identify bases. Bases end in OH, but not COOH. That's an important one. Or end in anything, blah, NH2. Or end in something COO negative. Or just end in a negative. Water is a base as well as an acid. That means sometimes it acts as an acid and sometimes it acts as a base. First thing I'm going to do is going to use my favorite rule, which is the hello, I'm an acid rule. So see how this one starts with an H? Hello, I'm an acid. Okay. This one. See how it just ends in a negative? That's a base. Welcome to base. It just ends in a negative. That's going to be a base. Okay, here I'm looking at COOH. So my COOH part, remember I said acids end in COOH? That's an acid. But I thought bases ended in OH. Here's an example of a base that ends in an OH. But notice it's not COOH. This ends in NH2. That means it's a base. How'd you know that? Okay, here we go. Bases, where'd I go? Bases end in NH2. CH3NH3 positive. Ending in something NH3 positive is an acid. If it ends in a negative, it's a base. Good. Yikes, yikes, yikes. Bronsted, Lowry conjugates. So, most acid-base reactions are equilibrium reactions, and they are acid-base reactions both ways. So this is an acid. Notice it gives H positive. Now, this is my reverse acid, so it gives, H positive. So if in my forward reaction, so notice this goes, whoop, whoop, whoop. Notice how it gave its H positive, and it turned into CH3COO negative. Do you see how this guy in the reverse, it's drawing my line funny. Notice how this guy, let's go to blue, gave its H positive and turned into F negative. The reverse acid is called a conjugate acid. It's still an acid. It still gives an H, but it's just called a conjugate. It's just on like the right side of the equation. So if I said there was, there's Chicago and there's East Chicago. East Chicago's in Indiana, if you didn't know that. What's the difference? Well, it's still a Chicago. What's the name of your city? Chicago. It's just on the east. That's it. Example, find the acid-base, conjugate acid, and conjugate base. So first thing I'm going to notice is this one doesn't have any H's. So that means I'm going to guess this is going to be a base. Bases receive H positive. So I'm going to look to see if this received an H positive. I'm looking for HPO3 negative 2. I found HPO3 negative 2. That means that's a base. Now, if this is the base on the left, that means this has to be an acid. And to confirm it, an acid loses an H positive. So if I lost an H positive, if this lost an H positive, the CH it would lose. I would see CH3COO negative, and I do. Okay. In the reverse reaction, I'm going to do the same type of thing. Okay. So in the reverse, going this way, if this was an acid, so I'm going to guess, is this an acid? If it's an acid, it's going to lose its H positive, and I would see CH2COO negative 2. I don't see that. Okay, this is not what I just drew here. Okay, so that means acid, no. So it's got to be the base. A base receives an H positive, so I should see CH3COOH, and I do. Because it's on the right-hand side, it's a conjugate base. So this guy over here has to be the conjugate acid because the bases and acids have to balance out. But if it's an acid, it must give up its H positive. So I'm going to look for PO4 negative 3. If it lost an H positive, I'll see, I said PO4 negative 3, PO3 negative 3. And do I see it? I do. So that's a conjugate acid. So that kind of tells you how to check it, okay? So, and knowing what they should be works pretty well too. Oh no, these both start with H's, right? So you know what I'm going to do? I'm going to start with my conjugates over here. This one doesn't have any H's, right? No H's anywhere. So that's got to be my conjugate base. So that means this has to be my conjugate acid. Okay, so now I'm going to guess. Okay, well, I notice right away that this HCO3 has to turn to CO3, right? So it's going to lose an H. So this is going to be my acid because it loses an H positive. So that means this would have to be my base because it would gain an H positive, and it does. All right. All right. So to find a conjugate acid, add an H positive. Treat the substance you are looking at like a base. So give the conjugate acid of NH3. I'm going to add an H positive. NH4 positive. If you thought HNH3 positive, that's really bad form. This is an ion you had to memorize, so you should be able to get NH4 from that. To find the conjugate base, treat the substance you are looking at like an acid. Remove an H positive. So what do acids do? Acids lose H's. So all I'm going to do is take away the H. Conjugate base of HNO2 is NO2 negative. Good. All right. Properties of acids. This is just the list of stuff that you've got to get used to. Acids start with H. H positive or H3O positive is what gets you. They taste sour and feel sticky. They react with metals to form gas. They change blue litmus red and is colorless in phenolphthalein. Their pH is less than 7. They're often juices from food. They conduct electricity. That's called being an electrolyte. Properties of bases are kind of the opposite. The OH negative is what gets you instead of H positive. They taste bitter instead of sweet. They react with organic material, denatures protein, dissolves bodies if you're a serial killer. My wife watches all those serial killer things. Changes red litmus blue and pink in phenolphthalein. It's slippery. pH is over 7. It's often a cleaner, and it conducts electricity. All right. think it's the last part. No, almost. Strong acids and bases ionize 100%. Okay, so what that means is HCl equals H positive. NaOH equals OH negative. Remember, brackets means molarity. That's the concentration of it, okay? Remember to double the OHs for poly-OHs. So 0.2 molar barium hydroxide is 0.4 molar hydroxide. Remember, you do not double the H positive for polyprotic acids. 0.2 molar H2SO4 is still 0.2, not so acids only lose one at a time, but bases lose them both. Look at a little picture of it. So remember how this strong acid is 100% ions, and this is not 100%, so a little bit less. Okay. Typically, it's 5% or less, but that's really hard to show that picture. So notice ion, 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 ion. What do you mean ion? Zoom in. Positive, negative, negative, positive, positive, negative. Over here, not an ion. So that means it's going to be weak. Okay. Another picture that we use to represent it, acid and water. So notice how these guys will turn into 100% ions. There are 6 strong acids: hydrochloric, HCl, hydrobromic, HBr, hydroiodic, HI, nitric acid, HNO3, perchloric, HClO4. And sadly, dude, you're going to have to memorize these. Get rid of that. So if you're not one of those, all other acids are weak. Strong bases are group 1 and 2 hydroxides. So remember, hydroxide is OH negative. Weak bases are other hydroxides or anything else that's a base, right? Water is a base as well as an acid. We heard that before. We'll hear it again. Weak acids and bases ionize less than 100%, typically 5%. Shown in pictures as 1 or 2 H positives and A negative. Most particles are still Ha together. Thank you for your time. Thank you for introducing yourself to acids and bases, and I will say, toodles.